Hello everyone, in this video we are going to be talking about the direct variation. There are basically four types of variation. We've got the direct variation, which we are going to be considering today, the inverse variation, the joint variation, and finally the partial variation. The direct and inverse variation are closely related because both of them involve two variables. So for example, if y and x vary directly, what this tells us is that an increase in y will lead to a significant increase in x, and if y decreases significantly, x is also going to decrease. Now, this is just the relationship between x and y is not just both of them moving in the same direction. No, it has to be by a fixed factor. The change has to be guided by a fixed rule. For example, if I go to a supermarket and I buy this box of cookies, so I've got 6 cookies here. If each one sells for $5 and I buy a second one, the same box of cookies, so I'm going to have to spend another $5. Now I know that if I'm going to need to buy an extra one right here, I know I'm going to have to spend an extra $5. So this is what is called a direct variation. So if y represents the amount in dollars and x represents the number of cookies, so what this says is that if x is 1, I'm going to have to spend $5. If x is 2, that's 2 times $5. If x is 3, 3 times $5. If x is say 100, perhaps I'm hosting a party and I need to buy 100 cookies, I know that I'm going to have to spend 5 times $100. So we can see that this is not just x going up and y following it. No, it is the fact that as x goes up, y also goes up by a fixed factor. That fixed factor is what is called a constant. Therefore, if y varies directly as x, the first thing we are going to do here is to change this sign. This sign is called the proportional sign or the sign of proportionality. So if y varies directly as x, we can also say y varies as x or y is proportional to x. The first step here would be to change this sign of proportionality to an equal to sign, and the moment we change it to an equal to sign, we are going to multiply whatever is to the right by a constant k. Thus, y being proportional to x implies that y is equal to kx. Now, like I said earlier, this constant k is the fixed factor establishing a direct relationship between x and y. Let's take a few examples. So we have that x varies directly as y squared. If x equals 12 when y equals 2, calculate the value of 1. X when y equals 3, 2. Y when x equals 75. So the first thing we are going to take note here is the direct variation. So we can see that x varies directly as y squared. So we are going to have x on the left of the proportional sign. So this is x varying directly as the square of y, that's y squared. So before reading further, the first thing I'm going to have to do here is to change this proportionality to an equal to. So this is going to be x equal to, and the moment this changes to an equal sign, I'm going to introduce a constant k to the right and multiply by y squared. So I've got x equals k y squared. So we have that if x equals 12, y equal to 2, so I'm going to sub the two values into the equation. So x is equal to 12. So this is 12 equals k. This is a product here. It's a multiplication. Then y is 2. This is 2 squared. So this is 12 equals 2 squared is 4. This is 4k. I'm going to divide both sides by 4. So this is going to give 12 over 4, and k is equal to 3. So we can see that the constant establishing the relationship between x and y squared is 3. Thus, I know where I'm coming from. This is where I'm coming from right here. Having obtained the value of k, I can go ahead to formulate the formula connecting x and y squared. Here is it. The formula connecting x and y squared is x equals 3y squared. The good thing about this formula is that it's going to allow us, since we know that in direct variation, we always have a fixed relationship between the variables. So this formula is going to allow us to obtain values of x for corresponding values of y, and similarly, values of y for corresponding values of x. And we are going to see that play out here. The first question here requires us to obtain the value of x when y equal to 3. So we've got x equals a question mark here and y equal to 3. Already we know the formula connecting both of them, x equals 3y squared. So this is just x equals 3 times, now y is 3, so this is 3 squared. So this is 3 times 3 squared is 9. So we can see that x is equal to 27. The second one, we are asked to obtain the value of y when x is 75. So as usual, I'm going to have to use the formula connecting x and y squared. That's x equals 3y squared. So already I know that x is 75, so I'm going to have 75 on the left equals 3y squared. Dividing both sides by 3 here. So we would see that 3 is going to cancel 3 on the right. 3 in 75 is 25. So clearly 25 equals y squared, which is the same as y squared equals 25. Taking the square root of both sides, so here I'm going to have the square root of y squared, and on the right, the square root of 25. The square is going to cancel the square root, so y is equal to the square root of 25 is 5. Let's take the next example. The question asks us to copy and complete the table for p varies directly as q. Here is the table. The first row contains the values of q, and the second row contains the values of p. There are some missing values here that we are going to have to solve for. Now we see that p varies directly as q. The first thing we are going to do is to change this sign of proportionality to an equal sign. And of course, we know that once we do that, we have to multiply whatever is on the right by the constant k. So this is going to be p equals kq. Next is to obtain the formula connecting p and q. And the only way to do this is by picking one of the columns that have both values for q and p. So that's the second column here. So we can see that in the second column, q is equal to 1. So I'm going to have 1. So I've got k here. And p is equal to 4. So this is 4 equals k times 1. Of course, we know that k times 1 is just 1. Therefore, the constant is 4. Thus, having obtained the constants, we can just write out the formula connecting p and q. So we know already that p equals kq. So since k equals 4, then the formula connecting p and q would be p equals 4q. This is the formula connecting p and q. It's also called the relationship between p and q. Now, having obtained this, we can go on to obtain the value of p when q is 3. So that's the third column here. We've got the value of q as 3 and p as unknown. So I'm going to call this equation 1. So substituting the value of q in equation 1, I would have p equals 4 times 3, and this is equal to 12. So I'm just going to fill this in. When q is 3, p is equal to 12. Similarly, here, q is missing. So I'm going to call this 2. P is equal to 16, and q is unknown. We're going to go back to the formula connecting p and q. That's p equals 4q. So p equals 4q. So P is 16. I've got this is 4Q. To obtain Q, I'm going to divide both sides by 4. So I see that Q is equal to 4. Thus, when P is 16, Q is equal to 4. I'm also going to do that here. Then finally, I've got the value of Q, which is equal to 5, 1/2. This is a mixed number. The first thing I'm going to do is to write it as an improper fraction. This is 2 times 5 plus 1. This is 11 over 2. And P is missing. The value of P is missing. I'm going to return to the formula connecting P and Q. That's P equals 4Q. So since P is unknown, this is 4 times Q is 11 over 2. So this is 11 over 2. So 2 can just reduce 4 twice. And my P is going to be 2 times 11. And this is 22. So I'm just going to fill this in. When Q is 5 1/2, P is equal to 22. Thank you for watching this video. If you find it useful, kindly like it by giving it a thumbs up, share to your friends and colleagues on social media, drop a comment, and click on the subscribed icon. To get notification if I upload new videos, just check the dark bell button under the subscribed icon. Thank you for watching once again, and see you in the next video.